It was the train too powerful for its own rails. In the age when America measured strength in steel, Union Pacific demanded a machine that could drag a mile-long freight over the Rockies, alone. The result was the Big Boy, an iron titan so massive its thunder shook mountains and its weight cracked the tracks beneath it. But why did the most ambitious locomotive in history become a victim of its own strength? This is the story of how the monster that outgrew its rails was built and broken by the very dreams that created it. Steel drove the American imagination. In the decades after World War I, railroads stood at the center of national pride, their tracks binding the country together and their locomotives rising as monuments to ambition. Every year, trains grew longer, heavier, and faster. Railroad executives and engineers, especially at Union Pacific, treated each new engine as a declaration of progress, a challenge to build bigger, haul more, and conquer the continent's toughest terrain. In boardrooms and roundhouses, size became a measure of success. The more steel poured into a locomotive, the more power it promised, and the more it seemed to prove America's industrial might. By the late 1930s, this obsession with scale had become a national ethos. Railroads competed to outdo each other, boasting of engines that dwarfed anything seen before. Newspapers ran stories about mile-long freights and titanic machines rolling across the plains. For Union Pacific, whose lines stretched from the Midwest to the Pacific, the railroad itself became a symbol of American possibility, an iron artery pulsing with the promise of growth, speed, and technological mastery. Yet behind the spectacle of smoke and thunder lay a deeper conviction that no obstacle was too great for American engineering. Steel was more than just a material, it was a statement of intent. The railroad's leaders believed that with enough ingenuity, they could bend the land and the laws of physics to their will. In this age of giants, no dream seemed too large and no machine too ambitious. The stage was set for a new kind of locomotive, one that would push the limits of what rails and the country itself could bear. Freight trains stretched for over a mile, loaded with wartime goods and raw materials, but the mountains refused to yield. The Wasatch Range and Sherman Hill stood as barriers, their grades rising to 1.55%, enough to bring even the most powerful steam engines to a crawl. Every major ascent meant a logistical headache. Dispatchers scrambled to assemble helper engines, sometimes 2 or 3 at a time, just to shove a single train over the summit. Schedules buckled under the strain as trains waited hours for their turn at the base of the hill. Crew rosters ballooned, fuel and water consumption soared, and the cost of each run multiplied. The bottleneck choked the main line, threatening to slow the flow of everything from coal to military supplies. Union Pacific's operations managers faced constant pressure. They watched as their ambitions for longer, heavier trains collided with the hard limits of the terrain. Every helper engine added meant another set of hands, another delay, another risk of breakdown on the grade. The dream of seamless transcontinental freight was slipping away, buried under the weight of the Rockies. It was clear, if the railroad wanted to conquer the mountains and keep pace with the nation's demands, it needed a single machine that could do the work of many. The search for a radical solution had begun. Otto Jobelman and his team at Union Pacific's Department of Research and Mechanical Standards, gathered in Omaha, determined to turn a logistical nightmare into a singular machine. They sent their requirements to Schenectady, where the engineers at the American Locomotive Company, ALCO, took up the challenge. The design that emerged was nothing short of audacious. A locomotive stretching 132 feet from coupler to coupler, weighing in at 1.2 million pounds with its tender. It would ride on a 4884 wheel arrangement, 4 leading wheels, 2 sets of 8 driving wheels, and 4 trailing wheels, an architecture never before seen at this scale. The engine's spec card read like a dare: 22 tons of coal, 25,000 gallons of water, a boiler pressure of 300 psi. Every line on the blueprint pushed the edge of what was possible. In the heart of ALCO's shop, as the first giant took shape, a worker picked up a piece of chalk and wrote 2 words across the smokebox: Big Boy. The name stuck, echoing through design memos and press releases, capturing the spirit of a machine built to do what no other could. With signatures and calculations scrawled across blueprints, the Big Boy became more than a solution. It became a legend in steel. To make a locomotive the size of Big Boy move through mountain curves without tearing itself or the track apart, Union Pacific and ALCO engineers borrowed from the mallet tradition, a system where the front engine set could pivot independently from the rear. At the heart of this design was a massive hinge, allowing the front 8 driving wheels to swing side to side as the locomotive entered sharp bends. This articulation meant the entire machine could snake through turns that would have stopped a rigid frame dead in its tracks. Beneath the boiler, a web of equalization bars and heavy-duty springs worked constantly to balance the load. With 12 driving axles spread beneath its frame, every dip and rise in the rail was shared across dozens of wheels, not forced onto just a few. The suspension system acted like a set of giant shock absorbers, smoothing out the ride and protecting both the engine and the track from sudden jolts. This careful distribution of weight kept the Big Boy's immense mass from crushing the rails outright, at least in theory. The true test would come when all that steel met the unforgiving realities of mountain railroading. Across the country, other railroads were locked in their own race for supremacy. The Chesapeake and Ohio's Allegheny, built by Lima Locomotive Works, boasted a staggering 7,500 horsepower, surpassing even the Big Boy on paper. Designed for the steep coal routes of Appalachia, the Allegheny hauled massive loads from the mines of West Virginia to the factories of the East. Its frame stretched nearly as long, its firebox wide enough to burn mountains of coal, yet its purpose was different. Brute force over short, punishing grades, feeding the industrial heart of the nation. Meanwhile, Union Pacific's own Challenger class served as a lighter, more versatile cousin to the Big Boy. With a 4664 wheel arrangement and a reputation for reliability, Challengers tackled mountain freight across the West, bridging the gap between speed and strength. Each railroad staked its identity on these mechanical giants, tuning their designs to the demands of their territory. The Allegheny and the Challenger each pushed the boundaries of steam, but only one would become a legend recognized far beyond the rails. Track crews braced themselves whenever a Big Boy thundered past. The rails would flex under the locomotive's weight, sometimes bowing just enough to catch the eye of a watchful foreman. After every run, maintenance teams found ballast churned loose and ties pressed deep into the earth. On certain stretches, rails showed fresh kinks or subtle bends, evidence of stresses that older engines never delivered. Bridge inspectors recorded stress readings near design limits, especially after heavy rain or a double-header haul. The men who worked the right-of-way spoke of the ground, trembling long after the train had vanished, leaving behind a network of small but growing wounds. Each run demanded repairs, new spikes, fresh ballast, replacement rails, turning routine maintenance into a running battle against the consequences of so much steel and power. The Big Boy's strength was plain to see, but so was the toll it exacted on the iron and wood beneath its wheels. By the early 1950s, a new kind of engine rolled onto the main line, diesel-electric locomotives, built not for spectacle, but for economy. Union Pacific executives, facing mounting bills from coal, water, and constant repairs, studied the numbers. Diesels ran farther on less fuel, needed smaller crews, and spent more time moving freight than waiting in the roundhouse. Where a big boy burned through 22 tons of coal and thousands of gallons of water in a single run, a diesel covered the same ground with a fraction of the cost. Maintenance records told the same story. Annual expenses for a big boy soared above $70,000, while a diesel's came in at less than half. By 1962, the last of the steam giants fell silent, retired not by failure, but by the quiet logic of efficiency and the relentless advance of technology. In 1941, Union Pacific unveiled the Big Boy, 132 feet long, weighing over 1.2 million pounds, built to conquer 1.55% grades that had defeated previous locomotives. Archival records confirm its articulated design and unmatched hauling power, but also document the strain. Bent rails, bridge stress, and rapid track wear followed in its wake. Maintenance reports from the era detail the costly upkeep that became unsustainable as diesel electrics arrived in the 1950s. While no complete set of original incident logs survives, surviving accounts from crews and engineers attest to the Big Boy's double-edged legacy. Its retirement in 1962 marked the end of American mainline steam, but restoration of engine 4014 in 2019 demonstrated enduring fascination. The Big Boy was too powerful for its rails, yet its engineering ambition still inspires. Today, it stands as evidence of an era when pushing the limits shaped both triumph and consequence.